Inefficient management of complex processes and workflows can create a lot of inefficiencies and wasted time, money, and other resources. Our project solution to that problem is creating a horizontal OM2M platform. What this will allow us to do is create a system that can easily accept multiple different types and amounts of sensors and output useful information for the relevant stakeholders. Now let's move on to our system architecture. So as you can see on screen, our system architecture can be broken up into three major groups. We have our hardware, our OM2M horizontal platform, and our data analytics. The hardware, as you can see, there's a multitude of different technologies in there. There's different types of microcontrollers and computers, and also different types of actual sensors. We have a heartbeat sensor in there, a Raspberry Pi, an Arduino, an RFID reader. And so what we're showcasing here is that our system isn't dependent on any single type of specific hardware. It can work with multiple different sensors and computers or microcontrollers. Next, we see different types of protocols being used. And this is important because, like our hardware independence, we're also protocol independent to some degree. We don't need to use only Wi-Fi, we can use Zigbee or Bluetooth. Now we're moving on to the OM2M horizontal platform. So here you'll see MNs and INs. Now the MNs act as sort of routers and localized servers. The sensor nodes will send their data to the MNs where they're stored locally. And as you can see, we have a ... MN subscript N. What this represents is the scalability of our system. If we want to add more and more sensors, we can easily integrate more and more MNs. And we'll discuss that further later on. And now between the MN and the IN, which is an infrastructure node, you'll see the HTTP protocol. That's the protocol we're using for communication between these two devices. The IN is sort of the master of the horizontal platform. All the data is ultimately stored on the IN, where, as you can see, it is sent to our cloud database. Now, our cloud database is what our data analytics platform will use to perform meaningful operations on the data. And it is also where our web GUI and our mobile application gets their final information from. So that concludes a brief overview of our system architecture, and now we're going to go into a bit more of a deep dive into each of these different parts. Sensor nodes, the hardware. So one aspect of our project and one of our goals was to make a system that can easily accept multiple different types of sensors and amounts of sensors. So how we accomplished that is we made it very, very easy to add a sensor node to the system. And a sensor node being a microcontroller / computer with sensors attached to it. So how we accomplished that is we made it very simple, where we have a simple script that you can run on your sensor node that sends the data to one of our MNs. So this way, scaling up, all it requires is the copy pasting of some simple scripts that we've already prepared for you. So another advantage of our project is that adding these sensor nodes and removing them does not break anything else in the architecture. Our data analytics platform and OM2M horizontal platform do not rely on any specific sensor nodes. They will both adjust accordingly. The MNs will adjust with which data they're receiving and not receiving, and so will the data analytics. Now, when we talk about how our system is hardware independent, one of the big reasons that's true is because our software platform can easily be adjusted for different types of sensor hardware. So for example, we'll look at the web GUI. So right now what you're seeing on screen is the process of creating a new service. Now service, our definition of it, is a collection of different sensors and thresholds that collectively give a meaningful information about a certain scenario. So as you can see on screen, it's very, very easy to check what sensors are in the system, group them together, and create a new service. And it can also be seen that if a sensor goes down, the rest of the services still operate just fine. We can also see that if you want to check a specific sensor value in the web GUI, that's also easily accomplishable. One aspect of our project is also its real-time capabilities. So far we've shown you is an analysis on a large data set. We can also have real-time alerts based on recent events in the system. So for example, let's say in a use case of a battlefield, A soldier's heart rate sensor indicates that he's no longer alive. In a matter of a few seconds, that information will be sent from the sensor node to the MN, to the IN, to our data analytics platform, where our data analytics engine, in combination with our server, will send an alert to the mobile application. Our project's goal was to create a system that's easily adaptable to any use case, can accept different and large amounts of sensors, and has a software and hardware independency. We achieved all three of those goals. Our OM2M horizontal platform can not only accept varying and large mass sensors, removing these sensors or adding completely new ones does not break anything in the architecture, and the software can easily adapt and accept those new sensors.